Today, lesson 10b, applications of systems of equations, day number 4. Today we finish off this idea of the type of problem that we sometimes refer to as a mixture problem, which we dealt with yesterday. But we've got two other situations that we need to look at. So a little bit of background knowledge from yesterday. Remember, we want to set up a total equation, and every part of that total equation will be in our cost or percent equation. In other words, we're going to have an x and a y, and whatever that total amount is, the difference is that we need to make sure that each of those bottom, those things in the second equation are then multiplied by either the cost as a decimal or the percent as a decimal. And then the first step is to make sure that we multiply the mixture dollar amount or percent times the total amount. And then it's just like the problems that we did before that. And then from there, you either use the substitution or the elimination method. And here was a problem that we did yesterday. And one of the things that I mentioned yesterday is I feel like it's important to at least in your mind think about what you are mixing together, because it tends to clear up any issues, especially with the kind that we're talking about today. So we did some with money values. And this was actually the one that I just had you set it up because it was a little easier. Yes? Not right now, no. And then we had these percent mixture problems that we talked about. And once again, both of these we did yesterday. So that leads us to, and I think I accidentally hit the back arrow, to number 1 for today. It says, how many gallons of a 50% acid solution must be mixed with 80 gallons of a 24% solution to obtain a solution that is 40% acid? So it's even more important today to think about what you are mixing together. So in this problem, we are mixing 50% with 24% to make 40%. Take a look at that and make sure that that makes sense to you. Does that make sense? Yes or no? Yes. Yes. All right. So I have questions for you. Do we know how much we have of the 50%? Yes or no? Yes. What? No. I heard somebody say yes. If you think it's yes, tell me how much we have of the 50%. Because when I read that problem, I think we don't know. So that means we will represent 50% with x. We're mixing that with 24%. Do we know how much we have of the 24%? Yes or no? Yes. How much? 80 gallons. Remember, this is our total equation right here. Do we know, now we're trying to make 40%. Do we know how much we have of the 40%? Yes or no? No. So we'll represent that with y. So you can already see that this type of problem varies slightly from what we talked about yesterday. Everything yesterday was x plus y equals this. But it's about thinking about what you're mixing together and thinking about whether you know what you have of each part there. Now, for the second equation, our percent equation, remember, every part of this one is part of the second one. The difference is that we need to attach to it the percent values. So since x represents 50%, 0.5 right there. Since the second value that we're mixing with that is 24%, we're going to multiply this by 0.24. And then we don't know how much we have of the 40%, and that's the percent part that goes right here. Any questions at this point? Same idea, but slightly different than the type of mixture problem that we talked about yesterday. Yes? Could you still solve this with elimination? You could still use, that's an excellent question. John asked if we could still use elimination. The answer is yes. You would just have to make sure that you put them both in standard form if you're going to do that. The first place that I would start is by multiplying both of these two things together. Can we do that really quickly, please? What is 80 times 0.24? What is it? 19.2. Now, it doesn't matter to me whether you use substitution or elimination, honestly, I probably would use substitution, but that's me. It doesn't matter to me. If you're going to use elimination, you need to put them both in standard form. I'll let you take it from there. I'm going to go ahead and take off my writing here. And I'm defining my variables. We already talked about what the total equation would be and the percent equation. And I went ahead and put the first equation in standard form. Same with the second equation. So I did a little bit of math there. And then I also multiplied the bottom one by 10, like I did yesterday. Because I think we would all admit that if we were to attempt to solve that system by elimination, that what I have now, compared to leaving things with decimals, you're much less likely to make a mistake there. So from there, I'm going to multiply the top one by -4 so that the y's are eliminated. Now, why did I choose to eliminate my y's when I normally eliminate my x's? Anybody have any idea why I maybe did that?
You only need to find the x value?
Yeah, it says how many gallons of 50%. So that's the only thing I'm trying to find. So why not just eliminate the y so that when I find my x, I have what I need. And you can see right there, I have 128 for x, so that means 128 liters of the 50%. I went ahead and found the y in case we get a problem where we had to do that, but really all that I'm looking for is the 128. Did I say liters? Yeah, we're finding gallons this time. 128 gallons of the 50%. All right. Do number 2 all the way through, please. Very important that you think about what you are mixing together, because that should clear up everything as you're setting up your system. In this problem, we are mixing 60% with 20% to make 50%. We do not know how much we have of the 60%. We do know how much we have of the 20%. That would be 30 gallons. And we do not know how much we have of the 50%. That leaves us with a total equation of x plus 30 equals y. From there, all of those pieces are part of the percent equation. We're just multiplying each percent as a decimal by each one. So that's where the second equation becomes 0.6x plus 30 times 0.2 equals y times 0.5, like that. And I would multiply 0.2 times 30, and then I would multiply everything in that bottom one by 10 to clear out the decimals, and then I like elimination better, so I would put both equations in standard form. So the total equation turns into x minus y equals -30. The bottom one turns into 6x minus 5y equals -60 after you multiply it by 10 and then put it in standard form. Any questions about how I came up with that? Because from there it should be easy. We are really only finding the number of gallons of 60%. So once again, I clear out the y's so that I can get what I need right off the bat there. So we get x equals 90, so that means we have 90 gallons of the 60%. And if I had to find the other one, it of course would be 120 gallons. All right, let's go with number 3. Number 3 says a 280 milliliter solution is 20% salt. How much water should be added to make the solution 14% salt? And unless you have seen something like this done before, you probably would not think about what you're doing. But what we are mixing here is we are mixing 20% with 0%, because typically water doesn't have salt, at least water that we drink. And we're mixing 20%, once again, with 0% to make 14%. Once you realize that, it's really identical to the first two types of problems. We do know how much we have of the 20%. That would be 280. We do not know how much water we have, the 0%. And we do not know how much we have of the 14%. So that leaves us with a total equation of something like that. Are there any questions as to how I came up with that for the total equation? Once again, once you realize that with water we're talking about 0%, this kind of problem is identical to number 1 and number 2. It's exactly the same. And then from here, we're going to multiply 280 by 0.2. We're going to multiply x by 0. And we're going to multiply y by 0.14, the decimal values for each of those. Now, what happens here is that second equation becomes very easy. Why do I say that? You just have to solve for y. You have 0x. It disappears. So I am going to go ahead and multiply 0.2 times 280, which gives me 56. But then look, that second equation becomes 56 equals 0.14y. So why not just take it and solve it for y? Let's do that. Everybody do that. What is y? What is it? 400. All right. So from there, you can just substitute 400 in right here, in my opinion. That's probably the easiest place. Because what we found was we didn't find what we were looking for. We need how much water, so that means we're solving for x. And when we do that, we end up with 120 milliliters of water. All right, any questions there? Once again, once we realize what we're talking about when we're talking about water, everything else is identical to number 1 and number 2. All right, I would like everybody to please try number 4. In this problem, we are mixing 5% with 0%. Skim milk has 0% butterfat to make 2%. And to me, once again, this is the key, understanding what it is that you are mixing together, because that should clear up everything as you're setting up your system. We know that we have 40 gallons of the 5%. We do not know how much we have of the 0%, and we do not know how much we have of the 2%. That gives us our total equation that looks something like this. Now you multiply the decimal values of the percent by each thing in that equation, which gives us this. I would multiply the 0.5 times 40, and then I would solve for y, because we have 0x, which means x is not there. That gives us 100 gallons of the 2%, but that's not what is being asked. What is being asked is how much of the skim milk. So we need to figure out how much we have of that, and that, of course, would be 60 gallons of skim milk. All right, one more problem. And I believe that it is probably a little closer to what we talked about yesterday than what we talked about today, but everybody try number 5. The purpose of this problem, and this is not the first time that I have given you a problem where it ends up happening what's happening in this one. Exactly the same sort of thing. Some of you are just going into automatic pilot, and you're setting up your system, and you're getting a negative answer, and you're thinking, well, I must have made a mistake in there somewhere, so I'm just going to make it a positive, and then I'm going to work it out from there. Right? That is what some of you are doing. When I walked around, that is exactly what I saw. But I'm telling you right now, this is why making a sentence is so important. Because here's what should have happened. What should have happened is you should have at least thought about that and then realized, oops, can that even happen? That cannot happen. So if you did go into automatic pilot and tried to solve it, you are going to get some negative answers. But not because you did something wrong, because it can't happen. Right? Here's a quick check when you make this sentence. This, since you are mixing these two things together, this mixture has to be somewhere in between those two. If it's not, it does not make sense. And if you go back and look at every single problem in the notes and in last night's homework for mixture problems, that has happened. This mixture has been somewhere in between those two numbers right there. But if it's not, it can't happen. So you would end up with no solution. And don't be surprised if one of those appears on Friday's quiz. Hint, hint, hint. All right, we are finished. Get your name on tonight's homework, and you may begin. And notice that I'm going to go ahead and do some work here, because this is what happened with some of you. You got negative 120 and you thought, well, I think I did something wrong, so I'm just going to use positive 120. But no, you didn't do anything wrong. It's just that you need to think about what you're doing before you even start. All right, we are finished.